All right, maybe you have these sequences of ANs, and we're asking ourselves, does this sequence converge as the n goes to infinity? Just taking the limit. And if it does converge, what does it converge to? Okay, so we think and we say, what is the limit as n approaches infinity of an? Or the limit as n approaches infinity of n over n plus 1 to the n. Plug in infinity, all right? Well, we get 1 to the infinity. That's not what we're looking for. It's in that indeterminate form. This is equal to L. And my gut reaction anytime we have 1 to the infinity is use logs. That way we can get that infinity down, get it back into the mode that we're looking for. So let's take the log of both sides. So we get ln of L is equal to the limit as n approaches infinity of n times natural log of n over n plus 1. Right? Because I pulled down the n with the log. When we plug in infinity here, we get infinity times log of 1, or 0. So we have that infinity over 0 part. All right. Same sort of trick. Limit as n approaches infinity of log of n over n plus 1 over 1 over n. And that way, we have a 0 over 0 format here. And we can use LHOP, or L'Hopital's rule. Limit as n approaches infinity. Okay? So we get 1 over this, which was just n plus 1 over n, times the derivative. Ooh, that's not a fun derivative to do. So let's do that really quickly. So we have to use the quotient rule. So we get n over n plus 1. The derivative of that is low d high, right? Low d high minus high d low all over this squared. So we're going to just get 1 over n plus 1 squared. All right, that's not too bad. So we multiply this by 1 over n plus 1 squared. Then we have to take the derivative of the bottom, which would be negative 1 over n squared. Let's simplify a little bit. Get the limit as n approaches infinity of, whoa, good, we got some cancellation here. 1 over n times n plus 1 all over negative 1 over n squared, which we can just flip this up to being negative n squared over n squared plus n, this limit as n approaches infinity. Oh, good. Good. Because this is just negative 1. Right? Divide the coefficients because we got two polynomials over each other. Are we done? Could say yes, but remember, got its natural log of the limit. So we have natural log of L equals negative 1, or in other words, L is equal e to the negative 1, or 1 over e. Pretty cool, right? Seems like a lot of work, but step by step, you have to take logs, take L'Hopital's rule, and you get quite a beautiful answer, if I do say so myself. Have a great day.